Hello and welcome back. Today I'd like to talk to you about sensors. For our next project we're going to use sensors because last time we learned about using lights, LED lights, and turning them on and off. Now we want to incorporate sensors so we can make them react to something. But first of all we need to know about sensors. There are basically two types of sensors. There are those that are just resistive, and then there are those that are intelligent. The difference is really, does it send you a signal depending on the voltage, or does it send you a signal generated from the IC itself or the sensor itself? So of course I got a few examples. The first one is, it's hard to see. I don't know what the yellow color is. Let's see. I'm going to show you on screen. Let's see. There we go. That's this one over here. There we go. This one. That's a LDR sensor. You can see it's a photoresistor. A photoresistor means a resistor depending on light, right? It has a resistance, and resistance either increases or decreases depending on your light source or the light in the area. These comes in a variety, as you can see in the software here. The software, not that one, this one, yeah. The software I'm using is 123circuits.io, and you can see I have three different that basically does the same thing. All they are resistors, and they return a resistance depending on light source. Some of them can actually be used as solar cells as well, so there you go. The other type we have is one of these I have on the back side. Yeah, it won't focus. Anyway, it's a not a thermistor, but a temperature transistor resistor. Sorry. It's going to send you a signal back, not a resistance, and the signal is going to be something you need to interpret to a temperature. And the one I'm showing is actually this one. It has three legs, meaning one of the legs has power in, one of the legs is ground or zero, and one of the legs is a signal. You can see it says V out right there. Of course, you could always argue that it's always a voltage out that you will receive. Yeah, that's true, but it's a signal, and we need to interpret the signal in order to know what temperature is it measuring. Luckily for us, there is a lot of people who has made some libraries that allows us to actually do this very easily. We're just going to include the library into our programming, and we can read the temperature. One of the other things we need to talk about is some of these big blue things. You can see it has three legs. It's very hard to see, it doesn't focus. It's a humidity measurement sensor. Yeah, it measures the air humidity, or so it claims. What it also does is it's measuring temperature, clearly, because air humidity and temperature goes hand in hand. This, however, the other one we just saw, can't pick it up now, the little black one, it can't measure the moisture or humidity in the air, while this one can. There's nothing inside except a chip, and it's connected to this board with three legs. Some of them has four. You need to make sure you connect to the right legs before hooking it up, because this will easily break. Last thing we're going to look at is this one. It's a hygrometer. It's measuring moist across these two forks. And it has a circuit. Basically what you could have done is just put two wires in your ground or water barrel or whatever where you want this to react. The smart thing about this is by using this transition and these forks you are not going to pull water or moist up into your wires. If I put 2 wires, unisolated wires, into the ground, I'm of course going to get a damaged wire over time. This way I only damage this part and it can easily be replaced, right? Well, if you're going to replace this, you would probably replace the entire thing, because it was, I think it was less than $1. So yeah. There is a integrated circuit on the end, or a small board. It has a potentiometer. That's a variable resistor. That's the blue box right there. You can screw in it with a screwdriver, right? There's also a small chip, and that's basically to interpret the signal for a digital output. You can see this one has 4 legs. It has power, ground, A0, which means analog 0, don't mind the 0, D0, which means digital 0. Digital means it's either on or off, meaning is there a connection or isn't there a connection. And the potentiometer is to determine when do you want a connection. Do you want it when there's just electrons flowing over, or do you want it when it's basically a short circuit of the system? So that's how you use the potentiometer or variable resistor. I never use the digital output on these because I like to measure the values. So I use the analog output. And the analog output, I can then set up my system so I can say, whenever we are at 50% moisture or lower, start the pump. And whenever we are reach 60, stop the pump. So we have a little of a space or threshold to work in. Good sensors. That's all you need to know about sensors right now. We're not going to discuss them any further, but we're going to discuss them in our next project, where we're going to use a sensor, or maybe 2. I think I'm making 2 projects there. And then I'll show you how to hook them up or use them in practice. The next thing I want to talk about in the next video is can you hear that? Yeah, that's buttons. These small guys, yeah, they're really small. They have 4 legs. Actually, they have 2, and then they have 2 parallel as well. Physically, they have 4. So next time we're going to talk about buttons, because we're going to need 1 or more soon. So thanks for watching, comment, rate, and I'll see you in the next video.